Welcome to the expert group. In the previous lecture, we discussed about the varistors, its uses, and its construction. Today, our topic is the SCR, the silicon controlled rectifiers. These are the current controlled semiconductor devices that has three terminals: the anode, cathode, and gate. This is basically a PNP semiconductor switching device which has these terminals containing anode, cathode, and the gate. If the two centers of the SCR are being split diagonally, then it will become two interconnected transistors, the TR1 and the TR2. The TR1 would behave as the PNP transistor, and the TR2 will be as the NPN transistor. With the anode positive to the cathode, the base collector junction are reverse biased, and apart from a small leakage current, no current will be flow. Then if a pulse is created into the gate terminal, then it turns the TR2 on, and this base current produces a large collector current in that TR2, which will also forms the conduction path for the base current of the TR1, which would obviously increase its collector current and forms the base current of the TR2, and it would behave as the self-sustaining the circuit, and the gate supply can be removed after it's becoming on. Then there are the types of the SCR conduction. Which first type is the P-type SCR conduction. You can see here the symbol of the SCR, which have anode, cathode, and the gate. And here specifically the shown figure is the P-type SCR. Here the condition comes that if the anode is more positive than the cathode, and a positive current sufficient to trigger the gate is applied, then the current will flow through the SCR. And then comes the next N-type SCR. Here you can see its configuration. Then if the anode is more positive than the cathode, and the negative current sufficient to trigger the gate is applied, then the current will go through the SCR. And that SCR after triggering to the gate would continue until the device is reverse biased, that is the positive to cathode or negative to the anode, or the second condition is the by removing the supply voltages, or the holding current limit would fall to a lower limit. The SCR will continue to conduct even after the gate current has been removed. The SCR will switch off only when the current flowing through the device drops below a specific level called the holding current. This is the typical operation diagram of the SCR. Here you can see by applying even the for microsecond the current to the gate, it would start conduction, and it would continue for conduction mode. It would be in conduction mode. If the anode voltage increases high enough above the cathode voltage to make the SCR break down into conduction, this would cause the break over voltage and may damage the device. It is very important feature that we have to remain in the lower limit than the breakover voltages. Then come the uses and advantages of SCRs. Can be made to carry a wide range of currents from single 1 ampere to a range of 1000 amperes. uh, these are a very wide range of current, and this in the specifically when we discuss we are talk about the aircraft systems. The SCR can be used in firewire controls, windscreen heating control systems. In windscreen heat control, the SCR can be gated at the beginning or at any point throughout the half cycle. The earlier it is gated, then the more current will flow to the windscreen, and if the later it is gated, then the less current will flow. The basic SCR that we see in this diagram will switch off after one half cycle, as the other half cycle will reverse bias the SCR, so it only allows half power through it. So further modified form, that is called the triac, which consists of two SCRs connected in parallel, but in opposite direction, and controlled by the same gate. It is triggered on both half cycles, and therefore if one conducts on one half cycle, the other one conducts on the other half cycle. Then comes the advantages, more advantages, that SCR has many advantages over mechanical switching devices, such as no moving parts, and no current arcing on the switching, no poor contacts due to the corrosion or dust. These are very smaller than the equivalent mechanical or manual devices, and they consume very less energy for switching. This is all about the SCRs, and for more videos, subscribe our channel, and thank you very much for watching.